up, athletes? Whoop, whoop. All right, welcome to 3.2. The learning target today is I will solve problems using the definition of similar polygons. Please forgive the blanket. I'm freezing. I can't see it, but down here I have like my heater on my legs, man. It's cold in this hizzy. All right, take a minute, write that down. Also, are the triangles congruent? Justify your answer. Ready, set, go. I'm assuming you paused it, so let's talk this through. See, this sides are congruent. These sides are congruent. These are congruent. This has side, side, side. Yes. Congruent. You would say triangle ABC is congruent to triangle. See, A is in between the 2 and the 3. 2 and the 3, D, E, F. Matters how you name these, okay? Oh, I used that triangle I made for the D. Kind of like a D. All right, let's look at these two triangles. They don't look the same, and it's saying these are 1, 1, and 1, and then 2, 2, and 2. So no, not congruent. So you put a slash through it. Okay, let's look right here. 90, 90, a 2, 2, and a 1, 1. That looks like side angle side. That's a thing, side angle side. So yes, we would say triangle JLK. You name whatever you want, but I'm going to say JLK is equal to triangle MON is congruent to triangle MON. Boom. Look at that. Awesome. Let's go down. We're going to go look at some vocab, y'all. Take a minute. This is transformations. Similarity transformation is a transformation composed of a dilation or a dilation of one or more rigid motions. So where a dilation doesn't necessarily, trying to get our notes, I'm going to remind you guys from back in the day. Non-rigid motion changes the dimension of a given figure. Rigid motion does not change the dimensions of a given figure. So it holds that dimension, holds the size, right? Just moves it or rotates it. So whereas similarity transformation is going to have a dilation at least, but then it could have dilation and maybe one or more rigid motions. Okay, similar polygons, or two figures are similar polygons if one can be attained by the other by a dilation or a dilation with one or more rigid motions. Similarity ratio is the scale factor between two similar polygons. Okay. Pause this, write them all down. We are moving right back. Okay. Right, see, I got them down there. We're going to move on to this. Actually, I don't know why I did that because we need to just go to our next slide, don't we? Okay, we're looking at 8.1. Let's fill that in. So the similar polygon. Looking at the angles, go ahead and draw on these angles on the drawing we gave you and write down corresponding angles. So we know that angle A corresponds to angle W, angle B corresponds to angle X, angle C corresponds to angle Y, and angle D corresponds to angle Z. So we're just corresponding. So we see A with W, we see B with X, C with Y, and D with Z. And that's why we have matching tick marks as well, or arc marks. If we're looking at sides, we can see this purple side of 18, so AB, or excuse me, let's start off with AB. So AB is 15, it matches WX, which is 5. We see that BC, good heavens, BC is 12, and it matches with XY of 4. And then we see that CD is 21, which corresponds or is similar to YZ, which is 7, and ZDA, which is 18, corresponds to ZW, which is 6. And notice we're doing a nice ratio over here. Write this ratio down. So we're saying AB over WX is equal to BC over XY, and so on and so forth, which is equal to 3 over 1. So it's a scale factor of 3, because if I divide this by 3, boom, 18 divided by 3 is 6. 6 times 3 is 18. Okay? Awesome. Pause this as needed. We're moving on. Oop, wrong one. At the end of the day, I'm a little bit tired. So you'll notice I have that all written down right here. Okay? All right. I also want to show you guys, and I'm going to just show it to you because it's kind of some confusing slides, and I want to make sure it makes sense. So, forgive the cross out there. We have theorem 8.2 as well, which is really, it's the properties of similarity, but there's really three of them. There's reflexive, symmetric, and transitive. And it's this. So the reflexive property of similarity just says triangle ABC is similar to triangle ABC. It's similar to itself. Triangle is similar to itself. Next, we have the symmetric property, which says if triangle ABC is similar to triangle DEF, right? So if ABC is similar to DEF, then we can say that DEF is also similar to ABC. That's what it's saying right there. And last is the transitive property of similarity, which we've seen transitive. It's the same idea. If triangle ABC is similar to DEF, and DEF is similar to XYZ, then we can skip the middleman of DEF and say triangle ABC is similar to triangle XYZ. Awesome sauce, guys. Pause that as you need, write down, ready, set, let's go. Okay, looking on back, we got some problems to work through now. After all those notes. Says, is triangle LMN similar to triangle ABC? If so, find the scale factor from ABC. And triangle ABC is similar to triangle LMN. Okay? Well, I'm going to need my calculator on this one. Gotta find it on my desk here. My desk is a mess. Okay, so number one, let's match sides here. Sometimes a highlighter will help you. We want to know, it says, is ABC or is LMN similar to ABC? So L should match with A. You see one angle mark there, one angle mark there. We see M should match with B. M should match with B, two angle marks. Which you know what that leaves? That means N matches C, and it has to. That third angle is going to have to be the same. If these two angles are the same and they all add up to 180, that last angle is going to have to be the same. Let's mark it in. 1, 2, 3, 1, 2, 3, boom. Which means LM, so notice when I highlight them, it's blue to pink, is going to match blue to pink. So it should be similar to, let's just do 3 divided by, misspoke, I didn't mean 3 divided by, I actually mean, remember we're supposed to go from LMN to ABC, so it should be 2.25 divided by 3, which is 0.75. That's 3/4. So LM over AB equals 0.75 or 3/4. Okay? And let's try BC, I'm sorry, MN over BC. MN over BC equals, let's see, MN is 5.25 divided by 7, 3/4 again, 0.75, 3/4. And last, let's go ahead and try NL divided by CA. NL divided by CA. See if that's the same thing, which is going to be NL is 6.75. 0.75 divided by CA is 9. 3/4 again. So yes, they are similar. And we identified the scale factor of 3/4. Perfect. Let's take a look at the next problem here. Just moving my face over to the left now. Boom. Okay, we see ACDF is similar to, gotta get out a fourth one here. ACDF is similar to VWYZ. I'm going to try that. So A should be similar to V. right? You match up the letters, and the order matters. AC, C is 2W. Third letter is D, third letter is Y, so D maps to Y. And last but certainly not least, F maps to Z. Does everybody see how that works? Find the value of Y. Well, if they're similar, then I know that 12, well, let's just put it this way, AF over VZ should be equal to CD over WY, correct? So let's plug that in. AF is 12 over 3y minus 1 should be equal to CD is 9 over 6. We're going to cross multiply to solve this. So I'm going to end up with 9 times 3y minus 1 is equal to 12 times 6, which is what? 72? Distribute this. We get 27y minus 9 equals 72. I'm going to add 9. And we get that 27y equals 81. I'm going to divide both sides by 27. I'm going to have to work backwards here. Sorry about that. I'm going to get that y equals, let's see, it's 81 divided by 27, 3. Y equals 3. Boom. See how that worked? Not too bad. Okay, we're going to go back to our notes so we can write down perimeters of. It has suddenly moved. Don't get too whiplashed, but all right. So, perimeter of similar polygons theorem says if two polygons are similar, then their perimeters are proportional in the same ratio as the scale factor between them. So, in other words, for these similar trapezoids, or not trapezoids, but these similar quadrilaterals, that's the word I was looking for. If I add up all the sides of AB, CD, and I add up all the sides of JKLM, that ratio is the same as AB to JK, and B, which is the same as BC to KL, which is the same as CD to LM, which is the same as DA to MJ. All right? Go ahead, take a minute, pause this, write it down, and then we're going to go finish up with our last question today. And it says, cosmetics. Adelita is going to attend a cosmetics and jewelry showcase this weekend. She had found a map online that shows all the booths that will be set up for the event. Adelita wants to visit the booths shown at points A, B, C, and D on the map. AB equals 3 inches, so AB is 3 inches. BC is 2 inches. CD is 3 inches, and AD is 2 inches. Perfect. Adelita wants to start at booth A and walk clockwise until she has visited all 4 booths and has returned to booth A. If Adelita follows this route, her walking path at the showcase will be similar to her path when it's drawn on the showcase map. What's the shape of her path? Well, it's a rectangle. That's what it looks like. Or one could even just say it's going to be a parallelogram or a quadrilateral of sorts, but it looks like a rectangle. And I know I didn't draw these going the right direction, but they are what they are. The actual distance between A and B is 30 feet. How far will Adelita have to walk to visit all 4 booths? Okay. Well, if it's actually 30 feet, then let's see what I know. Well, we know that 30 over 3 equals 10. So this is a scale factor of 10, and we're going from inches, I should have marked that, 2 feet. So that means I need to multiply each of these by 10, or you know what I can do? I can simply add them together. I can say, all right, 10 times 3 plus 3 plus 2 plus 2, which that's 6 plus 4 is 10, so this is going to be 10 times 10 equals 100 feet. She will walk 100 feet. And just to prove that this is true, I could have just multiplied each of these by 10, so that would have been 20 plus 20 plus 30 plus 30, which equals 60, 80, 100 feet still. Boosh. And that's all she wrote. So with that said, peace out. And pause this and write it down if you need it.